All right, so today the only difference is that we are now solving inequalities that have variables on both sides. We did this with equations already. We know that our first step when we are solving equations with variables on both sides is we need to move all of the variables to the same side. Well, when we do inequalities, what side do we like our variables to be on? The left. We like them to be on the left, so let's just, as a rule of thumb, always move our variables to the left. Let's take a look at example 1a here. I'm going to treat this exactly like an equation. I'm going to draw my line through the middle. I see I have b's on both sides, so I want to move that negative 12b to the left side. Anytime we are moving a variable, we are always using either addition or subtraction. Okay, we don't do anything else. There's no multiplication, there's no division. Variables only move with addition or subtraction. So I'm going to add 12b to both sides to get 4b plus 6 is less than or equal to negative 3. From here, I'm going to subtract 6. Now I'm working on isolating that b. So I have 4b is less than or equal to negative 9. And I finish it off by dividing the 4 away. So b is less than or equal to negative 9 over 4. We're not going to panic that it's a fraction. We don't really care that it's a fraction, as long as that fraction is simplified. Any questions on the solving part? Hopefully we're pretty familiar with the graphing part by this point. We're going to put our number right in the center. I'm going to pick a number bigger than negative 9/4 and a number smaller than negative 9/4. I'm not going to make my life harder than it has to be. I'm going to pick nice whole numbers. So a number bigger than negative 9/4, can I go with 0? And a number smaller than negative 9/4. Negative 9/4 is like negative 2.25, so let's just go with negative 3. Does that sound okay? B is less than or equal to negative 9/4, so I'm going to have a closed circle because of that equal sign, pointing to the left, because that's where the numbers smaller than negative 9/4 are. Any questions on that? Okay, letter B. So sometimes we have an extra step, of course. This time we're going to distribute before we can do anything else. I'm going to multiply that negative 3 to the x. I'm going to multiply that negative 3 to the negative 4. And then once again, I am going to move my variables to the left side. I am doing this on purpose, moving things to the left. To move that 7x, I am doing addition or subtraction. Am I going to subtract 7x or add 7x? We're going to subtract it. It's like a positive 7x here. So I undo it using minus 7x on both sides. To get negative 24 is left on the right side. And then inverse order of operations. I'm going to subtract the 12 from both sides. Negative 10x is less than negative 36. Divide both sides by negative 10. What's our rule for when we divide by a negative number on both sides? Flip the sign. So my sign is going to go from less than to greater than. Negative 36 divided by negative 10. We don't have to think too hard. We can just put it in our calculators, really. I don't care if you use your calculator. It's going to be a positive 3.6. You could keep it as a fraction. You could leave it as a decimal. I am fine either way. Whatever is easiest for you. 3.6 in the middle. One number bigger, one number smaller. This time I have x is greater than 3.6, so I have an open circle pointing to the right, where my bigger numbers are. Any questions there? Letter C. What's our first step in letter C? Before we can move all of our variables to one side, I have to do what first? Last time I had to distribute first. This time I have to subtract what? T minus 2t. Yeah, I'm going to combine like terms. T and negative 2t are like terms. I can do 1t minus 2t to get negative 1t, or just negative t. I'm going to move my variables to the left side. Here's something I want to point out because I saw this a lot on your test and I see it a lot on today's homework. When I move this variable to the left side, I'm going to, wait, first of all, am I going to add it or subtract it? I'm moving it to the left side. We're subtracting because this is a positive 6t, so I do the opposite, which is minus 6t. So that's a negative 7t over here. What happens on the right side of my equation, of my inequality? What is it? I'm hearing mumbling, and I'm not hearing a lot of answers. Read. I moved the 6. What happens on the right side now? What's left? So what do I write? 0. So if I have a 6t and I subtract 6t, they cancel out to make 0. On your tests, for some reason, I was getting a lot of this. 6t, minus 6t gives me t? That can't be right, because that's saying that 6 minus 6 is 1. And I was also getting a lot of just 1s, which is also not correct. If we are canceling something out, we subtract something minus itself, it's 0. It goes away. That's why we don't have to write it anymore. So that's one that maybe I would put a star next to that we can look back at, because that one was tricky on our test. Why do I have to minus the 60? Because I'm moving everything to the left on purpose. That's what I'm doing. I'm always moving things to the left here. You could have added the t to both sides if you wanted to, but then you have to do the switching at the end, you know. So then I get negative 7t is greater than or equal to negative 6, because I'm subtracting 6 from both sides. Divide both sides by negative 7. That should be t. What happens to my sign? Flips, because I'm dividing by a negative 7 on both sides. And then I have 6/7. I know. All right, put it in the middle. A number bigger is like 1 and a number smaller is 0. I'm going to have a closed circle this time because I've got that equal sign. And it says t is less than or equal to. So I'll face my arrow to the left. Any questions on that? Okay. Are we okay if I skip letter D? Okay. E and F. 2 people. Emma's got 1 and Jade's got the other one. I believe that's right. Yeah. Are you okay? Is it moving? Yeah. What's up? Okay. At least. I would look at that. Going along at least. I don't know what the end of your work went. Disappeared. Huh? Oh yeah, there it is. Jade wanted to do F. Oh, you're this way.
How do I press the back button?
Just erase with the back side of the pencil. Turn it upside down.
Oh, really?
Yeah. What the heck? I don't know why it's doing that. Just cross it out. I don't know what's going on. Oh, there it goes. I don't think it's 2. Did you do your subtraction right here? I think you did. Touch your subtraction again. 320 minus 200 is 20. No, it's not. Beautiful. Amazing. Okay. Oops. Any questions on these 2? We're going to do the word problem. We're going to knock it out of the park, and then we'll be good to go. All right. Example 2, word problem. It says, you already have $200 in your savings account. You want to save more money, so you decide to walk dogs in your neighborhood after school. You earn $10.50 per dog. If you want to save at least $320, what are the possible amounts of dogs that you could walk? What is our first step when we do a word problem? What's our variable here? The number of dogs. Let's call it D for dogs. Then I'm going to start looking at my word problem here. What am I looking for first? Or what should we be looking for first? The what? We can look for our keywords. What do I always say we look for first, though? The total. What's our total in this problem? 3? Oh, what is it? 320. Yeah, 320. So let's put 320 on the right side here. Now, what sign am I going to use in my equation? It says I want to save at least 320. Read. Greater than or equal to. It means I could save 320, but I could also save more than 320. What goes on the left side here? How am I going to set that up? How much money do I have, and how much money am I earning per walking these dogs? Perfect. $10.50 per dog, so times D, plus the 200 we already have in our account, has to be greater than or equal to 320. Questions on how we set that up? Now we're going to solve. So subtract the 200 from both sides. 1050D is greater than or equal to 120. Divide by 1050. To get that D is greater than or equal to 11.4 something, can we have 0.4 of a dog? So how many dogs do we have to walk at least? Read. At least how many dogs? 12. Yeah, at least 12 dogs. Could we walk exactly 12 dogs? Sure. Could we walk 13, 14, 15? Sure. Any less than that, we cannot. What I need to point out here is this rounding piece, though, because yes, that is the solution to this inequality, but you guys were getting half points taken off on that test because we can't have, I think it was delivery drivers. We can't have 0.7 of a delivery driver. We can't have 0.4 of a dog. So you got to make sure that you're rounding and your answer makes sense. Any questions on that?